Alright. Yo, what up? It's your boy. Alright, we're gonna do it. We're gonna hop into... Oh, I picked the worst place to put myself, didn't I? I'm right in front of the TV. Let me lightly move this away. Alright. So we're gonna do breakout for week 1, day 2. Setting this stuff up here. Whoop. Week 1, day 2. Does anybody know what we're doing today? Any ideas? Any kind of feeling of what we might be taking a look at? Scope. You did your quick research there, right? Yeah, so make directory. I'm going to call this one week 1, day 2, breakout. And I'm going to open it up in my Sublime. So week 1, day 2, breakout. Currently got nothing in there. We're going to fill it up over time. Quick check to make sure I'm not muted. Audio going through properly. Beautiful. Okay, so today's lecture or breakout is on scope. And a little bit more of how to read code. So scope and code. It's specifically in JavaScript. Oops. So notes.md. Specifically how we're going to do things in JavaScript. I'm going to write some more little demos along the theme of what we did in the lecture this morning. Not exactly the same, but along that theme. And the goals that I have set out for us are here. I'm going to write them out. Goals for today. Number 1, how to read code, i.e. reading and evaluating code in our heads. And the main kind of crux of that is going to be we're not going to read from top to bottom, so not from top to bottom, but rather we're going to mimic the way that computers read code. So mimic the way that a computer would read. That's number 1 goal. Number 2 goal is talking about scope. And by scope, I mean whatever the scope chain is, whatever that means. I will talk about scope a little bit more, and then more and more and more, and we're going to get there. But loosely, the idea here, and I'm going to use a phrase that's not going to make any sense. I'm going to say we're going to work at identifying different levels of scope. Different levels of scope. And we'll learn more about what that means. Now, today's lecture is, or the breakout is split into 2 parts. Beyond these 2 goals, we're going to have a whiteboard section that's kind of sandwiched between writing code, whiteboard, and then run the code. So this is this breakout workflow. Just giving you a heads up that I'm going to do things in an unconventional way, but it's still going to be neat. You might have noticed that I've dragged, with the help of, your name was? With the help of Ronan, we've dragged over the whiteboard. I have 2 whiteboard markers, and we're going to make heavy use of this in a minute. And the reason for this is that I'm going to write a bunch of little code challenges. I'm not going to run the code just yet, but I'm going to write the stuff, and I'm going to see if I can stump you. I want to stump you completely. I want to see if I can trick you with the way that the code's working, and you'll see what I mean about this in a sec. So notes.md, where did I save this? Week 1, day 2. I just need to save this in the right folder. Notes.md. Cool. So I got my notes. Next thing I'm going to do is we're going to call this challenges.js. because I'm going to write a whole bunch of code. As I said, these are going to be basically more and more versions of the same function over and over and over again, with slight kind of differences. Question 1. I have a function. Oh, you know what? Let's start even lower. Here is question 1. If I run my program right now, what happens? Anything? What's our hypothesis? Nothing. Okay, cool. So nothing happens. Okay, you're going to see the pattern kind of pop up here. Here's question 2. I've got a function called say best friend. Got a function called say best friend. Nah, you know what? I'm going to start even smaller here. I'm going to say var best friend equals, and I'm going to say my best friend today is Tyson. And I'm going to go down here and say console.log best friend. And to nobody's surprise, it should say Tyson. If I was to run this code, it should say Tyson. Okay. Question 3. I'm start moving this stuff around, and I will make var best friend is Tyson, and then I'll have a function say best friend, and in here it will console.log best friend. And let's see, what will I say in here? I'm going to console.log best friend, and also call say best friend. Okay, so this code here, what are the things that I expect to be printed out, and in what order? Yes. Undefined. How many times? Okay, so you're thinking with this code here, if I was to run this in Node, I would get hypothesis, maybe undefined, and then you said what was after that? Undefined and then Tyson. Does anybody else want to add their own hypothesis to this? Cool, so here's another hypothesis. Tyson. Yeah. Well, so what were you thinking I'd use maybe? Right. Well, I mean, we could say let as well. Right. In fact, you know what? Just for the purposes of this thing, let's just go let everywhere. Right? Because the examples that I'm going to use will not have any difference. Right? So, sure, I'll say let. Cool. So we got two hypotheses here: undefined Tyson and Tyson. The group's already starting to splinter. What's yours? Tyson undefined. Undefined. Okay, we've got some variations. Okay. Do the seniors want to put money on this? No? Okay, now they're busy. Okay, so this was question 3. Let's make it a little bit more interesting. Question 4. Okay. Still like similar in some ways to what we had here. I'm just gonna make this big so I don't have to keep zooming in. I'm gonna put enough space down here. So, question 4. I'm gonna do let best friend equal Tyson. I've got my function say best friend, and in here in this function, I'm going to have best friend equals Sneaky Hussein. Sneaky Hussein slips in and declares themselves to be the best friend. And then I've got console.log best friend. My code's not done yet. I'm going to say let's see, we're going to go console.log best friend and say best friend. So similar in some ways to what we had before, but I've added a line over here. What's our hypothesis now for what should be console logged out? Tyson and then Hussein. Okay, so we're going to go hypothesis, Tyson and then Hussein. Cool. Any other hypotheses? Was that yours as well? Sweet. So we got Tyson and then Hussein as the hypothesis here. Okay. Question 5. Essentially the same thing. Essentially the same thing, but I'm going to take this and move it up. So what are we expecting now? What do you think the output might be? Okay, so here's a hypothesis. You're expecting Hussein and then Tyson. Sure. Any other hypotheses? Right, let's really look at this code and try to think about what's going on. We're going to see this stuff on the whiteboard in a minute, but for right now. Okay, so the one hypothesis we have right now is Hussein and then Tyson. Do we all agree with that? Yes. 2 Tysons. 2 Husseins. Sure. So hypothesis, 2 Husseins. Right? Here's another one. Okay. I'm not saying that any of these hypotheses that we've put out are correct or wrong just yet. Right? I just want you to start thinking about it a little bit. I'm going to have 2 more scenarios. Maybe one. And then we're going to run through these scenarios on a whiteboard, right? And think step by step through what's going on. So I'm going to do question 6. So for question 6, I'm going to say let best friend equal Tyson. Whoops. I still have my function say best friend. And in here, I'm going to say let best friend equal Hussein. And then underneath, I'm going to do this. Say best friend. You know what? Let's do this. Console.log best friend. So there's 3 times that console logs are happening. Once here, and once over here. So what 3 things do you hypothesize will be printed? Yes. Tyson, Hussein, and then Tyson. So hypothesis, Tyson, then Hussein, and then Tyson. Cool. Does anybody want to add to this? No? Cool. So I'm not going to run this code. Not right now. Right, what we're going to do is scroll our way back up to the top and act as if we were the program running this code, right? We might run into some interesting things. We might not. Could I get a little bit of help just dragging that over while I move this? Cool. Just pull it up kind of like in front so it's kind of parallel to the TV this way. Oh, with the white edge out. So just over here. Cool. And then like right in front of me. Thanks. Perfect. And then we're gonna go on your face. Let's pull it back a little this way. Cool. And maybe a little bit further back until you're not on screen anymore. Beautiful. Thanks. Nice. Okay. So I'm gonna do my best to like whatever I write, make sure that it shows up on the whiteboard there. Okay, so, ooh, this has the effect of you not being able to see the code that I've written, right? Who can still see the TV somewhat? Oh, actually? Really? Okay. All right, so question 1 had been the one where there was no code written, right? No code. So on the whiteboard, nothing for me to really whiteboard. Fair enough. Question 2 was the one that said, best friend is Tyson, and let's console log best friend. Now, what you're going to see me do is acting as the node program that runs the code that we've written. If I see something that says let best friend equal Tyson, I, the node program, need to remember things, right? That's what a variable is. A variable is like a little pocket of memory where I'm going to keep track of things. So if I say let best friend equal Tyson, okay, here I am on my whiteboard, best friend equals Tyson. I've written this here, and now anytime somebody asks me about best friend, right, from now on, I can look at the board and I'll see, right, best friend is Tyson, I remember. So the first line says let best friend is Tyson, and the second one says console log best friend. Well, I as the node program look here and say, well, console log best friend, that is Tyson. Okay. Things get a little funky. Things get a little funky when we move into question 3. This was the one where the hypotheses really started coming in and where they started being a little differing. So can I just ensure that you're not able to see the whole TV? There's no, like, can you see, how many fingers am I holding up? What? Oh, okay. Let me scroll up. So, can you see all the way up to line 26? Okay. So, if I run through this program as node would, let best friend equal Tyson. Well, I have to remember who my best friend is. I'll write it down here. BF equals Tyson. And then there's a function called say best friend that does some stuff. Now, when node sees a function declaration like this, is it going to run that code? It doesn't run the code in the function until you call the function, right? So if it says function say best friend, who cares how much stuff is in that function? All I'm going to do right here is just say there's a function called say best friend. Just for reference for myself. I know that that function's there. And then I move my way down and it says console log best friend. Well, here's my best friend right here, Tyson. So I'll say Tyson. And then when it says say best friend, I hop into this function, and that's where things get a little bit funky. So I want to take a look at the hypotheses that we have. Our hypotheses were, I'm just going to write them down up here, right at the, there we go. Our hypotheses were, and I'll put them up over here, undefined and Tyson, Tyson and Tyson, and then there was Tyson and undefined. Okay. So in order to explain what's going on with this example here, in order to really follow along with what Node is going to do, I need to adjust the fact that at the moment I've just written out these variables or the functions that exist on the whiteboard kind of willy-nilly, right? I've just written this out. In reality, what goes on in a program like Node or like in a language like JavaScript is that we have something called the stack. And it looks a little bit like this. The stack is just a way of representing the memory, right? The way that the program's able to remember things. And anytime it needs to remember something, it'll put it at the top of the stack. We call it a stack because you add stuff on top and you take stuff off from the top. If I had a stack of dishes and I asked you to get me a dish, you'd probably take a dish from the top of the stack, right? I would be upset if you went and you tried to like pull one out from the bottom. And if I asked you to insert one, you would insert one on top. So that's the structure of the memory here, is when I make my way down the code and it says let best friend equal Tyson, that knowledge of Tyson gets put at the top of the stack. Right now there's nothing in there, so I'm going to put a little thing here that says best friend is Tyson. And then there's another piece of knowledge that says there's a function called say best friend. So I'm going to go in and say, okay, I need to remember that there's a function called say best friend. Okay, I'm just using some shorthand here for myself. When I then get into console log best friend on line 24 there, right? What Node or what JavaScript does is it looks at the stack and it'll work its way down. And the very first time it runs into BF, or like best friend, that's the value it's going to use. So I'm going to start from the top, make my way down until I see Tyson, so I console log Tyson to start off with. The next part of this is call the function say best friend, which goes here. And what you notice about the function say best friend is that it's got two curly braces around it. And the two curly braces for me indicate a whole new world, a whole new stack, a whole new world of possibilities. I think of these things as this is like your home world, and these are all little temporary worlds that pop up anytime a function gets called. Because we're going to see that inside of a function we can do all sorts of things. At the moment, inside of this function, in this function stack, I'm not saying anything between these two here. I'm not saying anything about making new variables, but I do ask about best friend. So JavaScript's going to go, hey, do I see best friend here? No. So I need to hop to the closest world, back to my main world. Do I see best friend here? Yes. And what's the value of best friend? Tyson. So I'm going to console log Tyson afterwards. Right? And this is just the mechanics of how the people who built JavaScript decided JavaScript would work. Right? This is what we're going to mean by scope, because you're going to see in the next example that I'm going to do stuff inside of here. So for our hypotheses here, this would be Tyson, Tyson. And when I run the code, you'll see that this is true. Are there any questions about what I just did here? Cool. So if we make our way down to question 4, is everybody able to see up to line 39? Nope. Is everybody able to see up to line 38, including? Gonna move it a little bit higher up. Okay. Or you know what? Let me just remove some new lines. Okay, is everybody able to see up to line 37? Beautiful. So what's going on with this question is similar. I say, hey, okay, we've got best friend is Tyson, which if I start here from scratch again, I'm just going to erase these. If I start here from scratch again, that means that this is empty. Means that I need to go into my stack and keep track of Tyson as best friend. I've got that function called say best friend, so I'm going to keep track of that in here as well. Function say best friend. And then I get to console log best friend, so just like I did before, I look at my stack and I see that best friend is Tyson, because that's what I had set it to be. So that whole first part of it works exactly the same. Where things get funky is when I call my function. Because what I'd said was, I have a whole new scope. I have this whole new world that gets created when I call that function. And in here, line 32 says, go set best friend equal to Hussein. So JavaScript's going to go look for best friend. It's going to go try and find it. And it will start in its home world. No, sorry, not the home world. It will start in the current local world. All right, I'll use more specific language as we kind of move on. I'm just going to start here, and it doesn't see best friend. So then it's going to go here, and it's going to say, hey, do I see best friend? And I do. I do see best friend. I see best friend right here, which had been set to Tyson, and I'm saying set it to Hussein instead. And then it says console log best friend. So again, it's going to start here, not find best friend, work its way over here and find it as Hussein. So what it will console log here is Hussein. And then interestingly, what happens is when you finish running a function, it will destroy everything that that function had brought into existence. Anything that that function had created will be destroyed. Right? This whole world is gone. But what happened? I have caused some side effects. I've changed something in the home world. And when the local, this little function here world was destroyed, best friend had been permanently changed to Hussein. So we're going to see the effects of this moving forward is this thing here permanently changed. Yes? No. So it doesn't happen only if you return something, because the thing is here, I had looked for best friend over here. I had found it over here and changed it to Hussein. JavaScript is stupid. It doesn't keep track of a history of things. So at the end of a function, when it goes and deletes all this stuff, it doesn't know that it's supposed to turn this back to Tyson, because how would it remember that? Right now I'm showing you all of the memory that JavaScript has, and the word Tyson, nowhere on this. Right? Nowhere on this. We're going to see a way around this in a minute. Can you imagine that if I had then asked to console log best friend afterwards, I would get Hussein forever until I go ahead and change it? Because it's been changed forever right here. So our hypotheses for this had been Tyson and Hussein. Tyson and Hussein, excellent. Right? Great. Okay. Can everybody see up until line 50? No? Let me make this a little bit smaller. Okay, is everyone able to see up to this line that I've highlighted? Cool. Is there anyone who can't? Cool. So, this example, somewhat similar. Somewhat similar, but what I've done is I've started off by running. Let me just make this nice and pretty again. I've started off by saying best friend is Tyson, so that goes in here. BF. So Tyson and Hussein are actually some of my friends, and I make my friends watch my lectures once in a while. So just to make them extra awkward, I add their names in. So best friend Tyson, I've got this function called say best friend, and then I call that say best friend function. I call that say best friend function, which makes this thing over here. Right? I've got a whole new world. It's going best friend equals Hussein, so it doesn't find it here. It moves over to this side and changes this from Tyson to Hussein. So poor Tyson never even got to be console logged. I've just got Hussein in here now. So on line 45, when I say console log best friend, what I get back is Hussein. Hussein. And now this is what I was kind of hinting at earlier, was at the end of this function, when I destroy this world, and I try to console log best friend, the only best friend that is found is Hussein. So I end up with Hussein twice. Again, this is something we call a side effect, right? When we're changing something that like persists after that function has been, run and destroyed. Is there a question over there? Saw like, oh no, you had like a lean in. I thought there was. Yeah.
Well, just whatever you call the.
Mm-hmm.
Say best friend.
Mm-hmm.
And you're saying in console.logs the best friend outside of the function, it doesn't read that one inside.
So this one here.
Yeah.
This one here goes and edits the best friend outside of the function, right? This one goes and edits it. And this one here is going to go console log the only best friend it can find, right? Right. So let's work through that again. On line 44, I say there's a best friend named Tyson, and I save it here in my stack. Best friend equals Tyson. On line 43, I say that there's a function called say best friend. On line 47, I call the function say best friend. So notice that I don't actually do this stuff until I get to 47. So on line 47 it says call the function say best friend, which pops me into here. And it says on line 44 that best friend is Hussein. So even though I'm in a new function, when it asks to change best friend to Hussein, since it can't find best friend here, it's going to go and change it here instead. Right? So best friend turns into Hussein. When I try to console log it, it can not find best friend in here, so it will find it here and console log Hussein. And after the function is done, on line 48, when I try to console log best friend, all I see is Hussein. So I get another one of those. Yes?
What do you mean by can't find? Because,
Mhm.
like, so I guess what I'm asking is, so in this other world, like, from the world, why doesn't best friend equal Hussein get logged there?
Exactly. So that brings us to the next one here, where the one difference is that I say let best friend equal Hussein. So let me just make this visible for everyone. Is everyone able to see up until line 60? Cool. Anyone not able to see? Great. So one difference to see here is that I've used the word let on line 55 inside of the function. And what let does, right, or what var does, right? I'm not going to talk about the differences between let and var today, but what it does is it creates a new piece of memory. It creates a new little piece somewhere that's going to store stuff. So when I make my way through this example now, right, best friend equal Tyson with the let on line 53 means in the global world, because this thing doesn't exist yet. In the global world, I say best friend equals Tyson. I get to line 54 that says there's a function called say best friend. I get to line 58, which says console log best friend, and I just did that as to show you the fact that like we would see Tyson right now, because there's no other best friend. So I get Tyson. At line 59, that pops me into this function. And the first line of the function says let best friend equal Hussein. So inside of this new world that function gives me, or I'm going to start using the word scope. Inside of this new scope, I am creating best friend equals Hussein. And the interesting thing about this is that it's not editing the thing that was in the global scope, right? It's making something in the local scope, right? So I'm going to call this global scope. I'm going to call this local scope. Right? It's creating a new thing in local scope. So when on line 56 I say console log best friend, JavaScript starts off by looking at the most recent local scope. And since it's able to find best friend over here, it can console log Hussein. After that function's over, this world gets destroyed, right? This scope gets destroyed, and I'm back to this scope. So when on line 60 I say console log best friend, there's only one scope for me to look at, and I see Tyson. So I get Tyson, Hussein, and then Tyson. Yes?
Say you called, say, best friend after the second log. Would it just be, it would be Hussein again, but with the second Tyson be Tyson still?
Yeah. So it would end up being, for anybody who didn't hear the question, say I switched around these two things, right? Is that what you're saying?
Oh, make it call, say, best friend again, because you're saying like when the function.
Oh, so 58, 59, 60, and then 59 again down here,
Yeah.
right? So if I did this right here, that line 61 would create the scope again, assign Hussein, and console log Hussein, and then delete.
So the world deletes after like the function on one line is called.
Exactly, yeah. So the scope ends at the end of the function, right? So when it comes back to the curly brace, when I've run all the code inside of that function, local scope gets destroyed. Does that answer your question as well? Mm-hmm. That's a good question. So you're saying, what if we got rid of like that? So if we had this, we start off with global scope. We start off with global scope, and the first thing that I see in memory is that there is a function called say best friend. Right? There's a function called say best friend. We run that function on line 47, makes a new scope. In that new scope, it says best friend equal Hussein. Since it doesn't say let, I want to say that what it does is goes and makes it in global scope. Off the top of my head, I can't remember, right? But I'm going to say probably. We could run it and see in a second. So yeah, I think that it would put Hussein here as best friend and then delete the scope after console logging it. We'll see. What we're going to do is take this code that we've written now and go to Python Tutor, which you'd mentioned. You had mentioned it, right? We're going to go to Python Tutor. We're going to see all this code actually run, right? And you'll be able to track things. And you'll be able to see the scope kind of evolve over time. And the examples that you can do using something like Python Tutor can be much more complicated than the examples that I can do just on the whiteboard, right? Are we kind of content with what I've done with the whiteboard so far? Cool. Now, things might still be hazy. That's fine. The examples are going to be sent out in the notes, and we're going to spend some good time with Python Tutor. Can I just get help moving this thing back? Cool. Thanks. And just here would be good, yeah. Thanks. Okay. So what we're going to do from here is, first of all, I'm just going to reuse the word call stack, right? So I'd say that that thing was a stack. I call it the call stack because when you call functions, a new stack gets created, and there's often many of these stacks, many scopes. One scope might spawn another scope that spawns another scope. So earlier I'd said the scope chain. And the reason I say the scope chain is because we've seen here starting from global making a local. But what I want you to play around with in Python Tutor, we might do a little bit of it, is make many different scopes. Like a function that calls another function that calls another function that calls another function. What does that mean? So the tool is Python Tutor. So there will be a link to this in the notes. The idea here is similar, like what I'd said in breakout this morning. If I write a for loop, for example, if I write a for loop and in here I do something like console.log I can ask to visualize the execution, and what that means is that I get this view that shows me the code. It shows me how many steps it's going to take to run that code. And over on the side over here, I'm going to see the console log values. And there's something interesting over here. So as I move my way forward, I can click forward, or I can even drag this little dude here. So I really just want you to pay attention to this thing. Is just that as I click through, I changes. Right? Now, I want it to be visible now with the examples that I'd written. So let me just edit and take those examples real quick. So we're going to start with challenge number 2. This one right here. And what we see is that when I say let best friend equal Tyson, the first thing that happens is that in the global frame, they call it frame here, the global frame as opposed to scope or stack, best friend is Tyson. So when I try to console log best friend, the only value that it sees is Tyson. I bring in question 3 here, and we get to see that funky local scopes start to come into play when I visualize execution, where I see that best friend is going to be Tyson in a second. So best friend is Tyson. And the other thing here is that say best friend, in the same way that I'd kind of drawn it on the stack, say best friend is visible and is pointing somewhere. As I make my way down the code, I console log best friend, so that's Tyson, and I say best friend, and I see a new little block here. So on Python Tutor, you'll see the global frame, and you'll see that particular functions frame. There's nothing to really do inside of the function right now. I'm just saying console log best friend, and it only sees it in the global frame. The hypothesis for, so just to really point it out again, it would be Tyson, and that's what we see over here, Tyson. Right? Oh. Question 4. This one here is where I write best friend equals Hussein inside of that function. And this is where we see this stuff in action with the going and changing the stuff in the global frame. Because as I click through, say best friend exists, best friend is Tyson, I try to console log best friend and I get, surprise, surprise, Tyson. But when I hop into say best friend, when I say to change best friend to Hussein, keep your eyes trained on this thing right here. What? Sneaky Hussein, right? Sneaky, very, very sneaky, goes in and changes best friend, right? And so when say best friend disappears, right? When that function disappears after Hussein has been console logged, Hussein is left that side effect. That side effect is there. So here, Tyson and then Hussein. We had done this example. I'm going to undo that comment and then we'll do the thing, because you had mentioned the comment? You had? So edit the code, run this, and what we're getting is Tyson is best friend. As we, whoops, sorry about that. As we move our way forward and we hop into the function, it changes the value to Hussein. Console logs best friend there, And then when it makes its way down there, that side effect is, you know, it rears its ugly head, and we get Hussein twice. You had asked about what if I didn't have this thing? Honestly, let's see. So we're running this code without this first piece. We have a function called sayBestFriend, and when it hops into there, and it says best friend Hussein, I don't know what it does. Let's see. It runs into an issue. Reference error, best friend is not defined. Right, since it wasn't able to see it on the stack and it's trying to assign a value to it, it doesn't know what to do. Right? So I guess that answers that. Any questions about this? Cool. Really good question though. And we'll do this last one, which is with let. And then we'll visualize things here. Whoa. Oh, right. When you run Python tutor after having had an error in it, it'll leave a little pop-up up here saying, hey, you fixed this error from the last time your code ran. I'm like, I don't care. Hide all of these pop-ups. Just so you know what that was. So as I make my way through here, I get best friend Tyson in the global frame. I hop into the local frame and I say let best friend equal Hussein, which means inside of the local frame I get best friend. And it has not tampered with that other best friend. This is a different thing. I make my way forward. Return value undefined. Bam, I got Tyson, Hussein. I'm going to get Tyson again because Tyson had never been tampered with. And now I hop into the scope again. Best friend Hussein, I can console log Hussein. So that was what you had added, the second function here. And then we're done. So what we're looking at here is I've boiled it down to the basic things you can do with scope. Is spawn new scope, play around with these variables, and then understanding that like when a function's done, that local scope is gone. I am going to, in the notes, put a couple more complex ones, such as in here, let's say there's let best friend Tyson, best friend Hussein, and I go let best food potato, and just some food. And then I try to console log best friend, and I console log, you know, potato. What do you think happens if I try to console log potato out here? Oh, what? I don't know why I wrote. I've just got the word potato stuck in my head. This should be best friend, best food, and best food. Right? If I console log best food in here, that's potato. Outside of here, it's not defined. Right? I get undefined. Right? Because this is a variable declared in local scope. This here is a variable declared in global scope. Does that make sense to everyone? Cool. Now, again, imagine if I had best food, this happening, right? And then inside of here I go say best friend and then say best food. How many scopes do I end up with? I end up with 3, right? I've got the global scope, I've got the say best friend scope, and then the say best friend scope also creates a say best food scope. Does that sound confusing to anyone? Right? It's totally fine if it is, right? What I want you to do is take this code, run it in Python tutor, and see what happens. Right? Honestly, I would recommend for a lot of the stuff that you're working on this week, take it and toss it into Python tutor and just see if it's doing what you expect it to do. Right? The stuff that you did yesterday, the stuff that you did for the katas and the prep work, why not go back if you have some free time, throw it into Python Tutor and get really familiar with it. Right? This is a great tool for learning, right, and for visualizing what's going on in your code. It is 3:58. So with probably like a minute and a half left, just want to say, are you enjoying day 2 of boot camp? Good time? Awesome, right? I hope, keep it up. Let me know if you do have any questions. Message me. I'm going to send you the notes and the video. And yeah, I'll see you all tomorrow. I'm not lecturing for you tomorrow, but I will kind of like peer in, and I'm mentoring. Great. Thanks, everyone. Oh, question. Oh, is it about the glasses again? Yeah. Of course, yeah. I'll be right there. Great. Thanks, everyone.